Hey there, Calc folks, back here with another video there in my my introductory videos here to Mathematica. I just put together that video for you on just what the fundamentals of arithmetic there on Mathematica and working just within Mathematica to begin with, some of the fundamental functions of math that are found in Mathematica and how they're all applied. Sine, cosine, tangent, right? Square root, cube root, cotangent, the e function, right? E to the x power, or the natural log function. And then even just not to show that I am not crazy here, folks. I even had an issue with what if I said if you wanted to do a log other than base e, you would have to use change of base, and what the heck was going on there? Let me bring this over, right? I notice if I do take something like the log of 9 and divide it by the log of 3, that is the change of base formula. That's like finding the log base 3 of 9. Mathematica reads the log as a base e. Now, what we did notice is when we enter that, we just get log 9 divided by log 3. It doesn't give us an exact value, and I don't know if this is because of the way Mathematica is approximating these values, but if I go back in and actually do a numeric approximation on that, I do get back the 2 that I'm expecting, right? 3 to the second power equals 9, so the log base 3 of 9 is 2, right? And this is just doing some logs of other bases here. So I knew that that works. I just don't know why Mathematica is not working with it. So I point that all out. Again, we can probably clear all that out. Let's just delete all that away and start fresh here. I'm going to put a title on this. Let's do let's call this common functions on expressions. All right. Let's say common functions on expressions. Let's say we had, for instance, the expression x squared times the quantity x minus 1 cubed times the quantity x plus 2 cubed. All right? Say we had that expression there. Now, you can see I went ahead and entered that into Mathematica. And again, remember there are two ways. Well, I've told you about one way to enter something into Mathematica. If you hold down the shift and press enter, that will enter a line of code for Mathematica into Mathematica and make it run that line. Or you can actually use the enter on the number pad, right? Use your little enter over on your number pad. And that's what I use 9 times out of 10. So I'll just hit that enter on my way through the calculation, folks. But one thing we can do on this expression, maybe we're interested in expanding it. So there is what's called the expand command. You can take any product of factors and expand it. And Mathematica will expand that, right? Expand it a heck of a lot quicker than we could expand that statement by hand, right? Similarly, remember we said Mathematica, you can use the percent to recall, so I can recall the last thing entered with the percent, but then let's say I wanted to factor what I had just entered. I can factor what I just entered and it'll go back into the factored form. In fact, you could factor any quantity. I could have the quantity x squared minus 6x. Right? Let's go with 3x squared minus 6x. Right? And let's now notice again, remember the syntax for Mathematica is you wrap your expressions, you wrap the things you want to apply these Mathematica operations with in brackets. So you'll see I did that in my expand, I did this in my factor, and I'm going to do it again here in this factor command again. I'm going to factor that, and it does factor it, right? The 3 factors out, the x factors out, and the quantity negative 2 plus x, or x minus 2, is left inside as a single factor, right? So factoring, Mathematica does factor for us, folks, really nicely. All right? It will do that factoring. Similarly, it will simplify. Right? Let's say we had again that 3x squared minus 6x as a quantity, and I could probably bring that back as a percent, but let's clarify. Let's say I had that as a quantity and I divided that by x minus 2. Right? If I enter that just into Mathematica, it's going to spit back out to me what I had entered. Right? But what I really want to do with that is simplify it. I can simplify that input. Again, I'm going to use the percent to recall that last output, 15 there. Simplify that, and you can see it does simplify. It cancels that x minus 2 found in both the numerator and the denominator. All right, folks. So that is just some common functions on expressions. Let's go a little further with this, and let's look at using Mathematica to do some solving. Some solving equations and inequalities and systems of equations and or inequalities, right? So let's see here. Let's give this a title. Let's look at solving equations, inequalities, and systems of equations or inequalities. Yes, that'll work for us. All right. And the way we're going to do this is with the solve command, folks. First of all, if we were to have an equation, let's say we wanted to solve an equation. Let's give ourselves a linear equation here. Let's say we wanted to solve the linear equation 2x plus 4y equals 10 for the variable x. All right. This is the way that I would put that into Mathematica here. All right. I would wrap what is going to be our equation. Now, notice 2x plus 4y, and then when I put an equal sign into a solve command, I don't use just one equal symbol. You actually end up using two equal symbols, right? We want where 2x plus 4y equals, and it's two symbols there, equal, one equal, second equal 10, right? But let's say we want to solve that for variable y, right? We wrap that, we follow that with a comma y, and then wrap that with the solve. Right? And this is going to solve that above expression, or this equation for variable y. Right? And it does say here y is this value 5 minus x over 2. I could also solve 2x plus 4y for the value of x. Oh, wait. You can see, what did I fail to do? Failed to make it an equation. And you can see, well, for x, it's just 5 minus 2y, right? That becomes our solution in that case. Right? What you will notice is that it does present the solution. Well, let's go further with this, right? Not only can you solve two variable equations for one of the variables, you can actually solve the equation. Let's say we were going to solve the equation. Let's go with x minus 3 squared plus 10 equals 0. Let's solve that quadratic. Let's solve that quadratic for x. Right? It does give us here, in this case, imaginary solutions. Let's go back and make it give us real. Let's do negative. You can see there it gives us these real solutions, right? Before we were opening up, now let's open down and actually cross the x-axis. That's why we had imaginary solutions here. And we can actually even put in more than one condition into our solutions. This does have two outputs. This does have this negative output and this positive output. We could make it so that it just gives us back the positives. And the way we would do that is we would add on an and condition. We would say here and we do that with a double, what is that called, an ampersand simple, right? Double ampersand. Then we would say let's only want the x's that are greater than 0. And we can use the greater sign. And it'll only give us that solution. Or maybe we only want the ones that are less than 0. And I can get just the negative solution out. All right. If I wanted just the ones that also equal 0, right, certainly that has no solution. We get a failure with all that, folks. Right? But that is solving these systems. Now, putting your limitations on x is one way to get these solutions out individually. Another way is to realize that you are given a set of values here. And you can, this is a set of two values, this solution here and this solution here, right? Where you can isolate the solutions by following that solution command with the solution you'd be interested in. If I only want the first solution, I could do double brackets 1, and it'll just give me back the first solution in that set. Or in that set, I could get back just the second solution by following it with a double brackets around a 2. The other thing you'll notice is it gives you this funky notation, or really not this funky notation, but it says you have a set of two answers here where x, right, equates to or is equivalent to 3 minus the root 2, and x is equivalent to 3 plus the root 2. And it doesn't say that with an equal sign. It says it with an arrow, right? What you can do with that arrow is you can replace the values with that arrow. If I had another statement like 3x plus 4, I could replace that solution. I got to be careful there. That's the solution for this. I could take the solution for this. There. Yeah, I could take the solution for this, and I could take it and plug it into another function like 4x plus 5. And the way I would do that is taking 4x plus 5 and following that with this notation, the forward slash followed by a period. This is a way of saying replace with or replace all. All right. And if I run that code, it's going to replace all the x's with the quantity 3 minus root 10 in this first case and 3 plus root 10 in the second. And if I wanted to actually simplify that, right, we could maybe expand that. I could get my, got that sign backwards. Get a nice expanded and simpler form out of that. What do I got going on here? Let me get rid of this. Just hanging out there. All right. Another thing you can do with a solution, right? What I like to do is sometimes you can notice here it dropped out that x value. So actually you could call this out as a set, or we could just call it x. Yes, if we just call it x, it will, and do the replace with, it will just give us the solutions, and we'll ditch the x with the arrow notation. Right. That is a way of just getting a solution out numerically. Right. And like I said, you could then even at that point call this another value. Right? And this is getting a bit into equations. I should probably hold off on that. Or once you have that other value called, you could declare like, well, we just want the first value, or we just want the second of that value. All right? Thinking of these as a set of solutions for S. But that is solving. The beginnings of solving. You can solve systems this way. Maybe we're interested in solving the system of equations where 3x plus 4y equals 10 and x minus 2y equals, and then remember, make sure you use your double equals. Let's go with -1, right? And we want to solve this for variables x and y. And you can see there I followed that where I would normally just have my, let me bring this up, sorry. Where I would normally just have my variable x in my solution, my solve command, following my inequality, or my equality statements here, separated by the double and symbol because I want to solve a system. I want to solve these two things simultaneously. The variables I want to solve for are x and y, and we're going to treat those as an ordered set, right, where x comes first and y comes second. And you can see there is the solution to that system. Right? And certainly you could step up your systems, right? I could have a three-dimensional system plus 2z. Now this may not have a solution. Minus 8z equals 11. And then let's say here x plus y plus z equals 15. Now there's a lot of conditions going on here. We don't get a solution out for that specifically. Remember, you're looking for one point where they all intersect. But maybe if we put that limitation on, no, not quite. What if we made x equal to 15? All of a sudden we're getting issues there. System of equations are equal. Oh, you know what it was? I didn't have my equal sign in there. X double equal x plus y plus z equals 15. There we go. And that does have a solution, thank God. Right, we do have a solution for the intersection of those three planes. Which does work. All right, that is our x, y, and our z value. Now that's solving equations. To solve inequalities, let's say we had 2x plus 5 is less than or equal to. Now you can see here you put a less than in and then an equal, and then if you follow that with a number, you can see what it often does is it'll convert it over to a less than or equal to sign on its own. And let's say we want to solve that inequality. You would actually use what we call the reduce command. And it'll say x is less than or equal to 5 halves. Now it automatically went ahead and solved that for x. Right? You could also follow that with the variable of interest there. If we had 5x plus y is less than or equal to 10, solve for x. Well, it would say y would then be a real number, and x would be anything less than or equal to 1/2 the quantity 10 minus 5y. So Mathematica gets very literal in its solution here for that reduction, or the reduce formula, folks. I have worked with compound inequalities. Maybe we want something like, let's reduce where 2x plus 3 is less than or equal to 10, greater than or equal to negative 10. And notice it doesn't have to convert over, but if it doesn't, you can always just space there, and it will. Or, how do you do or? It's a double vertical bar. Right above your enter on your keyboard is you have a vertical bar. If you hit shift and that button, that key right above enter, you'll get your absolute value symbol, and you can do a double absolute value, right? And maybe we say here x is plus 8. Let's say that's less than 9 and greater than or equal to 3. Or I say 3 and I write 2. Let's go with 2 then there, I guess, right? And let's solve that for x. Let's reduce this inequality for x. It will solve that compound inequality. Right? That or combination of ands. And you could even do an and combination of ands. What would an and look like? Does it have no solution here? Remember, and is the overlap. There's where these two solutions would overlap, folks. Right? In terms of their solutions. So that is solving equations and inequality systems, right, of equations also on, and I guess solving systems of inequalities here also. Can we do systems? What happens if we do reduce where x plus y is less than or equal to 1 for x and y? It says x is any real number and y is less than or equal to 1 minus x, which is quite literal to the solution there. It is that region below this line 1 minus x. Right? If I wanted to solve that just for y, it will solve that. And if I wanted to solve that just for x, we could also get that solution out in the context of x. So if I wanted x plus y is less than or equal to 1 and 4x minus 6y is greater than 0, And let's solve this system for x and y. Two inequalities, two variables. We should have a solution, and this is our solution. X is less than or equal to 3/5, and y is less than 2/3 x. Or x is greater than 3/5, and y is less than or equal to 1 minus x. And it will solve that system of inequalities there, folks. Really, really fun stuff Mathematica will do for us. All right. Again, there's a bit more advanced operations on Mathematica. What did we see here? We saw the reduced and solve command, simplify, factor, and expand, folks. Working with these ideas. All right. But yeah, we're at about the 20-minute mark, so I'll stop my video there, and I'll come back to another one. What we have next to look at is we're going to start working with tables and plots. How to make some tables and how to do some plotting, some fundamental in terms of plotting. And then doing some work with functions, declaring our own functions. This is all going to require us to declare some of our own functions, folks. And we will do that when we return here in my next video. So, with that said, I do think I'm going to wrap it up right about here, folks. So, see you in the next one.